Now see a few conversions. So if I want to say step up a reaction, I am saying change methanol into ethanol. So this is methanol containing one carbon atom. I want a compound containing two carbon atoms. So the first step is for any reaction is to change it into an alkyl halide. Now alkyl halides are the most reactive compounds. So first step is to change into this. You can use HCl, PCl5, SOCl2, so many reactions you have now written. So change it into an alkyl halide. Second step is called a cyanide step. So I'll divide it into two. Cyanide is added. Cyanide contains a triple bond. So with cyanide I have increased the number of carbon atoms. Now there are two carbon atoms here. This compound on reduction changes into an amine. So there is a triple bond here. If I attach one hydrogen, say I am attaching hydrogen, one here and one here, it will become CHNH. It will become a double bond. But if I want to change it into a single bond, once again I will have to write down another hydrogen. So 4 hydrogen atoms are going to change it into CH3, CH2, NH2. So CH3, CH2, NH2, and amine is formed. And amines react with nitrous acid to form alcohols. So OH, NNO, you've written this reaction also, will give you an alcohol. Second one is a step down reaction. That is, I am changing a compound with 2 carbon atoms into a compound with 1 carbon atom. So you already know alcohols change into an aldehydes, change into an acid. So 2 carbon atoms, 2 carbon atoms, 2 carbon atoms. So careful of writing down alcohol, aldehyde and acid. Now reacted with ammonia, you already know H and NH2 we write for ammonia. So this heat is very, very important here. So ammonia takes away this water molecule from here. CH3CONH2 is formed, which is an amide. CH3CONH2. Now, a very special reaction takes place here, bromine and KOH, which is called Hoffmann-Bromamite reaction. Hoffmann is the name of the scientist. Hoffmann-Bromamite reaction. So remember that I am using bromine, I am using amide, and the reaction's name is Hoffmann-Bromamite reaction, which steps down the reaction. So this is actually the complete reaction. Amide plus bromine plus KOH. This CO part is lost. It becomes CH3NH2. And CO part changes into a carbonate. So basically this is the complete reaction, which can also be asked separately. When we'll do amines, we'll again come back to this reaction. But at the moment, you remember that in presence of bromine and KOH, this CO part will be lost and amine containing a lesser number of carbon atom will be formed. So CH3NH2 is formed. Maximum children make a mistake in writing bromine. Like you write Cl2, same is with bromine is Br2. So this is formed. Again I have reacted with HNO through OH, NNO, and alcohol is formed, which now contains a lesser number of carbon atom. The third one is if I want to change primary into secondary. Now whenever you want to change the place of anything, I want to change the place of OH from here to here, because this is primary alcohol. If I change this OH at this place, it will become secondary alcohol. Whenever you want to change the place, you will always first change it into an alkene. So I can do dehydration, which is in presence of concentrated sulfuric acid at 170 degree. Remember to write down the temperature. It changes into an alkene because I have removed OH from here and hydrogen from here. Alkene is formed. Alkene on reaction with HBr will use Markovnikov's rule. So Br will come here, H will come here. So CH3, CHBr and CH3 will be formed. Now if I react with KOH, aqueous KOH, be careful. If I am using aqueous KOH, this will be replaced, OH will come here and Br will be replaced as KBr. So now I have got a secondary alcohol. So primary alcohols to secondary alcohol. Third one is if I want to change secondary alcohol into tertiary alcohol. So first step will be, you know secondary alcohols on oxidation change into ketones. So secondary alcohol is this CHOH. If I remove this, oxidation means removal of hydrogen. So removal of hydrogen takes place and this compound changes into a ketone. So when it changes into a ketone, now react with Grignard's reagent. One more CH3 will be attached here. You remember this. NGBr gets attached here. CH3 gets attached here. So first step is an addition reaction. This compound form. Then with the help of water, which will be HNOH, I can change it into an alcohol containing OH at this place now, which is a tertiary alcohol. So tertiary alcohols will be formed first by oxidation and then using Grignard's reagent, which will attach one more methyl group, change it into a tertiary alcohol.